You can see preparation of the complete brain preparation, and the arachnoid with the pyometa covers hemisphere. Granulationes arachnoidalis, Pacchioni granulation, through which the subarachnoid fluid outflow into the superior superior sagittal venous sinus. Telencephalon, the last part of the brain, which together diencephalon develop from prosencephalon, anterior brain vesicle. Telencephalon consists of hemispheria, two hemispheria separated by means fissura longitudinalis cerebri, by means transverse groove separated from the cerebellum. Fissura longitudinalis cerebri starts from the lamina terminalis, this layer of the brain matter delimited the longitudinal groove from inside lamina terminalis, from which corpus callosum starts. These two hemispheria don't complete separated. Between hemispheria what structure lies? Corpus callosum. If you will cut on sagittal section, this is sagittal section of the brain, you can see corpus callosum. What does it mean? Corpus callosum, it is example of commissural fibers. Commissural fibers, fibers which connect the symmetrical cortical centers with each other. And this is corpus callosum on section. It consists of we'll start from the lamina terminalis, then rostrum, geno corporis callosi, truncus corporis callosi, splenium corporis callosi. Lamina terminalis, rostrum, geno, truncus, splenium. This commissural body connects two hemispheria, yes, between two hemispheria. Each hemisphere consists of three poles: polus anterior, polus posterior. The anterior part is most developed, the better developed part of the brain, because the frontal lobe is the best developed part of the brain. All the highest conscious, highest mental activity of the brain depends from the frontal lobe of the brain. And this is occipital lobe, this is frontal. Temporal, frontal, occipital, temporal, three poles, three surfaces. This is dorsolateral surface of the hemisphere, medial surface, and inferior surface of the hemisphere. They are separated by means superior margin, inferior margin, and lateral margin. Three surfaces, three poles, three margins, and we will describe structure of each hemisphere. Telencephalon consists of pallium. Pallium translated as coat. Like coat, it covers all other parts of the brain. The brain stem, truncus cerebri, cerebellum, covered by hemispheria. Like coat, our coat covers. In Latin, coat is called pallium. Pallium consists of the brain cortex, which is formed by gray matter, substantia grigia, you can see substantia grigia, and white matter, substantia alba. Gray matter, white matter together form pallium. On the pallium we can see sulci and gyri. Sulci, and between them gyri. At fetus, 2 months during intrauterine life, the brain is smooth. Any grooves are absent in fetus. In fetus, the brain is smooth. It is called lissencephalic brain. Lissencephalic. Starting from the 3rd month of intrauterine life, the brain, on the surface of the brain appear the gyri, because the cavity of the skull cavity is delimited, and the brain grows, and on the surfaces are formed these sulci. And lissencephalic brain becomes gyrencephalic brain. Starting from the 3rd month are formed the sulci and gyri. At first appeared primary sulci, for example, sulcus centralis rolandi, it is primary constant groove. Sulcus lateralis silvii, sulcus parieta occipitalis. These grooves, or sulcus calcarinus, these 4 grooves you can find in any brain. Mm-hmm. Each hemisphere, any hemisphere will take you very easy can find these grooves. They appeared on the third month. They are characterized very constant and present in all hemisphere. Secondary grooves are formed starting from the 5th, 6th month. They are not so more vary, not so constant. For example, inside the frontal lobe, sulcus frontalis superior, sulcus frontalis inferior, sulcus temporalis superior, sulcus temporalis. They are secondary, and numerous tertiary, more small grooves appeared on 8, 9 months and after childbirth. They are called tertiary grooves, which delimited this very compound relief of the brain. And even in one person, right and left hemisphere, they differ from each other. And this tertiary groove delimited specific individual relief of the external surface of the brain. You must remember that gray matter, which forms the cortex, in medulla spinalis we have gray matter where? Inside, yes, and white matter outside, because the neural tube has inner ependymal layer, middle mental layer, and external layer, marginal veil, from which white matter develop. In the case of the brain vesicle, this middle layer, mental layer, neuroblast, they migrate on the surface of the brain vesicle like acrobat on the rope. They migrate along the glial cells. They migrate on the surface of the brain vesicle, and externally this 3 and later 5 primary brain vesicle, they are covered by gray matter. Gray matter and white matter weight among the weight of the brain about 1,145 gram average weight of the brain in female, and 1,345 at male and female. No, about 1,200 gram average weight. 581 gram is formed by pallium weight, gray matter, white matter, and only 21 gram forms the cortex. 21 gram, from this 21 gram of gray matter depends all our high mental activity depends from this gray matter. 21 gram, and 560 gram forms the white matter. And gray matter lies not only on the surface, the common surface of the surface. Pallium is about 2020 square millimeters. And the majority of the 2/3 of this gray matter lies in the thickness, not on the surface. And from 1 to 5 millimeters. From 1 to 5 millimeters is the thickness of the gray matter. And gray matter consists of 6 layers. Histologically, this 6th layer, you must study the name of each layer, especially first and second association, third and fourth internal pyramidal, fifth external pyramidal layer, and polymorphic 6th layer. All these 6 layers of the gray matter. We'll describe sulci and gyri on the surfaces. Then we'll describe white matter. Together from what? Pallium. One part of telencephalon is pallium, with gray matter, white matter, sulci and gyri on each surfaces. Then we'll describe in white matter aggregation, accumulation of gray matter. In distinction from the superficial gray, they are called subcortical nuclei. For example, these, they are located not on the cortex, but under the cortex. They are called subcortical nuclei, subcortical ganglia, or another name, they are called basal ganglia. Why basal? This is dorsal surface of the brain, and this is ventral surface of the brain. If we will cat, and reach near the base of the brain, we can find this gray matter nuclei, nucleus caudatus, nucleus lentiformis, claustrum, and only in specific frontal section of the anterior medial part of temporal lobe, the amygdaloid body or amygdala. They belong to basal ganglia or subcortical ganglia. It is another part of the telencephalon. Pallium with gray matter, white